Today is 14th October 2025. Alishba is absent. Atif is absent. So I am recording class for them. And the topic is electromagnetism, which is started in Pavithra school. So, and I think Atif is joining. Yes. Hello, beta. Assalamu alaikum, Atif. Beta Atif, your school teacher started electromagnetism. So I am following your school. And before starting electromagnetism, I am teaching you some basic information about magnet. So let's start magnet. Sir, what is magnet? But a magnet is made of iron oxide, Fe2O4. It is ore form of iron, and if you suspend a metal bar with the help of a string, consider you are hanging this metal bar freely with the help of a string, then its one end always point geographical south of earth, and we call this end as a south pole, and the other end which is pointing always towards geographical north of the earth, it is called north pole. So there are two magnetic poles at the end of a metal bar, at the end of magnetic bar. So there are two poles. Okay. And use if I place a magnet compass, magnet compass is like this. Consider this is plastic case, and in this plastic case there is a pointer. There is a pointer. One end of the pointer is red, the other end of the pointer is blue, and these are usually this red pointer represents north pole and the blue pointer represents south pole. And I will show you a video during the class in which I will show you the physical form of magnet, the physical form of this compass, and if you place this magnet compass at this position, then you will find the red end of the pointer is repelled by the north pole of the bar magnet, and if you mark two dots with the pointer and then move the compass in the forward direction, then you will find again the direction of pointer changed, and keep on pointing, keep on marking at the end of the pointer position. You will find the pointer position like this, and you are moving forward with the magnet compass, and the direction of the pointer, the direction of the magnet compass is keep on changing. Why? Because the north pole of the bar magnet repelling the north pole of the magnet compass, and as you are moving the magnet compass in forward direction, then the direction of pointer is keep on changing, and finally you have reached the other end of the bar magnet. And if you join all these points, if you join all these points, then it is like this. It is the north pole, it is the south pole, and if you join all the points, then you will find this kind of magnetic field. And this magnetic field is made of magnetic lines of forces, and you have to memorize. So these magnetic lines of forces are starting from the north pole, pointing towards the south pole. These magnetic lines are starting from the north pole, ending at the south pole. So I have drawn few magnetic lines around the bar magnet. Okay, this is called the magnetic field around a magnetic bar. This is the magnetic field around a magnet bar. And if you watch this video, which is hardly 2 minute video, but it will show you how the magnetic field can be produced around a magnetic bar. In this video, you can see this is a bar magnet, and the teacher is drawing boundary line around the bar magnet, and now placing this magnet compass and pointing marks in the direction of red pointer. You can see the end of the pointer is red color, and you can see the direction of pointer is keep on changing. So now the teacher is joining these dots, and these dots or these magnetic lines are starting from the north pole, ending at the south pole. And now the video is fast, and the same work is repeated at the faster rate. And now you can see magnetic lines or magnetic field is drawn on either sides of the magnet. These magnetic lines never cross each other. These magnetic lines are pointed from north to south pole. This is the north pole, red end, the blue end is the south pole. These magnetic lines are continuous. Continuous means the region where I did not draw the lines, actually I did not draw, but there are magnetic lines. Where the magnetic lines are very close to each other, the magnetic field is stronger. At the poles, magnetic lines are very close to each other, so the magnetic field is very strong. Is magnetic field is very strong, or where the magnetic field lines are far apart, the magnetic field is weak. So this is just an introduction of magnetic field. As well as you should know iron, steel, nickel, and cobalt. These are called magnetic substance. These are called magnetic substance. And these materials are attracted by a bar magnet. Iron is attracted, steel is attracted, nickel and cobalt are attracted by magnetic bar. Okay, bar magnet attract these magnetic materials. So these are magnetic material, and glass, wood, cloth, etc. These are non-magnetic material. Non-magnetic material means they are not attracted. As well as copper, aluminum, etc. These are metals, and all these metals except iron, steel, nickel, cobalt are or all are non-magnetic material. So it is the basic information of natural magnet. This is the basic information about natural magnet. Okay. And now if we talk about electromagnet, sir, what is electromagnet? So if you pass electric current through a wire, consider this is a wire, and this wire is carrying electric current, and if you pass this wire through a cardboard, consider this is a cardboard. Acha beta, I think some student has unmute herself or himself. I think Atif. Okay, but Atif, you have muted now. Acha beta, this is a wire. This wire is passing through a cardboard, and when electric current is passed through the wire, a magnetic field is produced around the wire. Sir, how do you know there is a magnetic field around the wire? So I am explaining. If you switch off current and now sprinkle iron fillings around the wire on the cardboard. And now you can see this iron filling having no certain pattern. It is a scattered way iron fillings are spread on the cardboard. And now I am passing current through the wire. And now tap gently on the cardboard. And as you tap this cardboard, then these iron fillings are arranged in a certain pattern. These iron fillings, and I can show you a picture from Google, from internet, a beautiful pattern are formed in a circular shape. A magnetic field is produced around the wire, and it shows that when electric current passes through a wire, a magnetic field is produced around the wire, and the study of this magnetic field is called electromagnetism. Electromagnetism means the magnetic effects which are produced by electric current. The magnetic effects produced by electric current. This study is called electromagnetism. So when electric current passes through a wire, a magnetic field is produced around the wire, and its study is called electromagnetism. And as I told you earlier, there is a magnetic field around a bar magnet, and this magnetic field is pointing from north to south pole. So now I am asking, what is the direction of magnetic field around the wire? What is the direction of magnetic field around the wire? So according to the rule, we apply right hand grip rule. We apply right hand grip rule. So what is right hand grip rule? The right hand grip rule is, if you point your right hand thumb in the direction of current, if you place your right hand thumb in the direction of current, and now grip the wire virtually, not really. If you grip the wire in your hands, if you grip the wire by your right hand fingers, then the direction of fingers, then the direction of fingers will tell you the direction of magnetic field. If I ask you, Atif, because I think we have discussed this chapter earlier with Atif. Atif, beta, if you apply right hand rule and I am asking you, you have to tell me, sir, the direction of magnetic field, will it be clockwise or anti-clockwise? हाँ बेटा आतिफ, place your right hand thumb in the direction of current. Right hand rule, okay Atif? Right hand thumb in the direction of current. Then what is the direction of your right hand fingers? Is it, you are saying it is anti-clockwise? You are right. The direction of magnetic field is anti-clockwise. The direction of magnetic field is anti-clockwise. But if you watch this video, then I think this concept will be more clear. This concept will be more clear. So what is the concept? The concept is, this is a wire which is connected with a cell, and now I am going to connect the wire with the cell, and as the wire is connected with the cell, obviously current begins to flow. Now you can see the wire is connected with the positive terminal of the cell, and now the current is passing. You know, current is the direction of flow of positive charge. Okay, this is the direction of current, this is the direction of current, and in the direction of current, the right hand thumb is pointing. The right hand thumb is pointing in the direction of current, and these are right hand fingers, and these right hand fingers showing the direction of magnetic field. Right hand finger showing the direction of magnetic field. So I think, Ammar, is the concept clear? Place your right hand thumb in the direction of current, and the fingers which are gripping the wire, and the finger's direction is the direction of magnetic field. So when electric current passes through a straight wire, you can find out the direction of magnetic field. And conversely, if the current is passing in downward direction, then obviously when the direction of current is reversed, you will see the direction of magnetic field will also be reversed. And you can see if the current is downward, then the direction of magnetic field is clockwise. And this is the side view. This is the side view. But sometime in your exam, you are given top view. Sir, what is the meaning of top view? Top view means consider you are watching the wire from the top of the wire. Okay. And if you watch from the top of the wire, then it is possible the current is out of the page and current may be into the page. If current is out of the page, we use a dot. This dot shows the current is out of the page. Current is out of the page. When the current is out of the page, then I am asking you what is the direction of magnetic field. But Pavitra, can you help me in applying right hand grip rule? And if the current is out of the page, then keep your thumb towards your face. And if the thumb towards your face, then what is the direction of magnetic field? Is it clockwise or anti-clockwise? Pavitra, you are saying clockwise. It is totally wrong. The direction is anti-clockwise. Pavitra, are you using right hand or left hand rule? If you apply a right hand rule, if you apply right hand rule, and if you keep your right hand thumb towards your face, when the thumb pointing face, then now apply a right hand rule. What is the direction of your fingers? Is it clockwise or anti-clockwise? It is anti-clockwise. And conversely, if the current is out of the page, then we draw cross. Cross means cross means current is into the page. Current is into the page. And if current is into the page, then again I am applying right hand grip rule, and according to the right hand grip rule, it is difficult to place thumb towards the screen, and now my fingers are pointing clockwise direction. My fingers are pointing clockwise direction. And remember, the spacing between the magnetic field lines, this is short spacing, it is large spacing, it is more large spacing. It means the spacing of magnetic field line increased as we move away from the wire. Sir, why? Because the magnetic field lines are close to each other. It means magnetic field is very strong here. Very strong magnetic field here. Because the magnetic field lines are very close to each other. But here, the gap between the magnetic field lines is large. So the magnetic field is weaker. Magnetic field is weaker. So magnetic field is weaker as we move away from the wire. Okay. So this is the rule of right hand rule we have discussed. And now I am talking about a solenoid. The right now we have studied straight wire. This is straight wire. We have discussed straight wire. And now we are going to discuss a solenoid. So what is solenoid? Solenoid is a coil of wire. This is a coil of wire. And now this coil of wire is connected with a cell or with a battery. And now I am connecting this wire with the cell or a battery. And now the switch is on. and now the current is passing through the solenoid. So when current passes through solenoid, again a magnetic field is produced. And remember, the magnetic field around a straight wire, sir, it is very weak. It is very weak, and it has no significant application. But when wire is wound in the form of coil, the magnetic field is very strong. And this magnetic field is very significant, and it is used in our daily life in different applications. We use solenoid. And now let's start with the theory of solenoid. So when electric current passes through a solenoid, a magnetic field is produced around the solenoid, and we can determine the direction of solenoid, or we can determine the north pole and south pole of the solenoid. And the rule is if the current if the current is passing through this solenoid, and if you are watching solenoid from here, if you are studying solenoid from this point, if you are watching solenoid from this point, but Atif, can you help me? When current is passing through this coil, but Atif, this current is clockwise or anti-clockwise from this view? Atif, from this view, the current is clockwise or anti-clockwise? This is clockwise. And if the current is in clockwise direction, here will be north pole. Here will be north pole. And obviously the other side will be south pole. Other side will be south pole. Okay. So if you view the coil from right hand side, and if the current is in clockwise direction, for clockwise direction there will be north pole, and the other side there will be south pole. And in exam you will see, sir, you will be given this kind of coil, and they will ask, draw the magnetic field around the solenoid. You have to draw the magnetic field around the solenoid. You should practice. And the answer is, sir, you know the magnetic field lines are starting from north pole to the south pole. So you should draw magnetic field like this. You should draw the magnetic field like this. This is a magnetic field around the wire. This is the magnetic field around the wire. And if you add arrows, it will be more better. If you add arrows, it will be more better. And what is the direction? So direction is from north to south pole. From north to south pole. So magnetic lines around the solenoid is just like the magnetic field around a bar magnet. And these magnetic lines are also pointing or directing from north to south pole. And I hope just after my class you should draw a magnetic field at least once around a solenoid. You should draw a magnetic field around a solenoid at least once. Okay, so we have discussed, sir, what we have discussed, sir, we have discussed magnetic field around a bar magnet. We have discussed the magnetic field around a straight wire. We have discussed the magnetic field around a solenoid. And now I am starting our next topic. So what is the next topic? The next topic is, sir, how can you magnetize an iron rod or a steel rod? I think it is better. An iron rod as well as a steel rod. We will discuss both. Okay. An iron rod, and then we will study a steel rod. I am starting with iron rod. Okay, I am starting with iron rod. Consider this is a solenoid. Consider here is a north pole. Consider here is a south pole. And I have inserted an iron rod inside the core of solenoid. The region inside the solenoid, it is called core. So I have inserted an iron rod inside the core of solenoid. Then according to the rule, the this end of the iron rod becomes north pole, and the other end of the iron rod becomes south pole. So same poles are copy pasted. The same pole of the solenoid and the same pole inside the iron rod. But remember, sir, iron is a soft magnetic material. Iron is a soft magnetic material. Sir, what is the meaning of soft magnetic material? Soft magnetic material means iron. As current passes through coil, the iron magnetized very quickly. Very quickly. There is no time delay. As the coil becomes magnet, the iron rod becomes magnetized. But as you switch off current, then the iron rod demagnetized. So you can say iron is a soft magnetic material. It magnetizes and demagnetizes very quickly with no time delay. With no time delay. It magnetizes as current passes through the solenoid. It magnetizes. When you switch off current, it is demagnetized. There is no time delay, and iron rod is a soft magnetic material. That is why iron rod is always used in the core of solenoid. Iron material is used as the core of electromagnetism. Iron rod is used in the core of solenoid. Why? Because it magnetizes and demagnetizes very quickly. There is no time delay. Okay. But sir, if I use and if I place a steel rod inside the solenoid, sir, then what happens? I'm going to explain. Consider this is a solenoid. Consider electric current passes through solenoid, and now you are placing a steel rod in the core of solenoid. And as current passes through solenoid, solenoid becomes magnet, but a steel rod does not. A steel rod takes time. There is a time delay. It does not respond quickly. Current passing through the coil, but the steel rod is not magnetized. It is taking time. And after few minutes, the solenoid is a magnetic is a magnet, but a steel rod is not magnetized right now. But after few minutes, you will see here will be the north pole in the steel rod, here will be the south pole in the steel rod, and now it is magnetized. But it takes time. But when you switch off current in the solenoid, you have switch off, but the magnetism in the steel remains same. But the magnetism in the steel rod remains same. It does not lose magnetism. Sir, why? Sir, because steel is a hard magnetic material. Hard magnetic material means It takes time in magnetism and it takes time to demagnetize. It does not respond quickly. It takes time to magnetize. And when it is magnetized once, then it becomes a permanent magnet. It has become a permanent magnet. And permanent magnets are used in our daily life in different appliances. So steel rod becomes permanent magnet, whereas iron rod is a soft magnetic material. It magnetize and demagnetize very quickly. There is no time delay. It depends upon current. If there is a current, then it is magnetized. No current, demagnetized. But steel rod, it takes time to magnetize, but when it is magnetized, then it becomes a permanent magnet. It becomes a permanent magnet. Beta, Pavitra, are you there? May I ask you a question, Pavitra? Beta, Pavitra, what is the difference between iron rod and steel rod in electromagnetism? What is the difference between them? Iron rod and steel rod, difference in electromagnetism. Sir, iron is a soft magnetic material. Steel is a hard magnetic material. Iron magnetize and demagnetize very quickly, no time delay. But steel takes time to magnetize, and when it is magnetized once, then it becomes a permanent magnet. If you switch off current, but it remain magnet. Why? Because it is a hard magnetic material. Ji beta Pavitra, say something about steel and iron. All the material is available on the screen. Say something. Pavitra beta. Perfect. Perfect explanation. Perfect explanation. Okay, beta. So we have completed the iron and steel difference. And now, and now, we are going to start demagnetization. Consider you have a steel permanent magnet and I want to demagnetize a permanent magnet. So, sir, we have three methods of demagnetization. We have three methods of demagnetization. Number one, by heating. If you heat a permanent magnet, if you place permanent magnet into the flame, then it loses magnetism. By heating, you can demagnetize. In the same way, by hammering, you can demagnetize a permanent magnet. But the most efficient method is electrical method. And what is electrical method? Electrical method is, consider this is a solenoid. This is a coil of wire. But this coil of wire is not connected with a cell or a battery. Now today it is connected with AC supply. AC supply, and generator produce AC current. Okay. In the above explanation, we were connecting the solenoid with DC source. With DC source, DC is used to magnetize steel rod. DC is used to magnetize steel rod. But right now we are interested to demagnetize. So we are connecting this coil of wire with AC supply. And now if you insert this permanent magnet, consider this is a permanent magnet, consider this is north pole, consider this is south pole, and now you are interested to demagnetize this steel rod. So place permanent steel rod, permanent magnet steel rod into the core of solenoid and now pass AC through the coil. Remember, current is not passing through the magnet, current is passing through the coil. Current is passing through the coil, and if the current is AC, you know AC current changes direction. AC current changes direction. So I cannot draw the arrows of current, so I have removed my arrows because AC keep on reversing direction. And if you place this permanent magnet into the core of solenoid for few minutes and then either gradually reduce current or withdraw steel rod slowly from the core of the solenoid, then the steel rod will be demagnetized. Okay, number one, either decrease alternating current gradually and then switch off. Then you will find steel rod which was permanent magnet, now it is demagnetized. The other method is, sir, move if you withdraw the permanent steel rod from the core of solenoid slowly, then it would be demagnetized. It would be demagnetized. So, but in today's class, we have discussed the first topic, that is natural magnet. Natural magnet is an iron ore. Its chemistry formula is not necessary to memorize, so I am erasing. It is an iron ore. Magnet, permanent magnet is usually an iron ore. And if you hang this iron ore, permanent magnet, with the help of a string freely, then its one end always point geographical south. It is called south pole. The other one pointing geographical north. It is called north pole. And there is a magnetic field around the bar magnet. And this magnetic field you can draw with the help of a magnet compass. These are magnetic material: iron, steel, nickel, cobalt. Non-magnetic material which are not attracted by magnet: glass, copper, aluminum, copper, cloth, etc. When electric current passes through a wire, there is a magnetic field around the wire, and the direction of magnetic field can be determined by right hand grip rule. Then we studied a solenoid. Solenoid is a coil of wire. When electric current passes through solenoid, then north pole and south pole are formed. In the solenoid, I have taught you the rule where is north pole, where is the south pole, but you should practice to draw the magnetic field around a solenoid. And then we study, if you place an iron rod inside a solenoid, then iron rod is a soft magnetic material. As current passes through solenoid, it becomes magnetized. When current is switched off, it demagnetized. There is no time delay. But if you place steel rod takes time. It is a hard magnetic material. So we have discussed the difference between steel and iron, and then we studied how do we demagnetize a permanent magnet. There are three methods: heating, hammering, and electrical method. And in electrical method, we have discussed alternating current is used to demagnetize a permanent magnet, and we have discussed the method. I have shared you my notes in which the theory which I have taught you today, because today there is no formula, there is no calculation, so notes are significant. If you read my notes, then all the material I have written in my notes, and tomorrow we will start past paper questions, and in past paper questions I will write properly answers from the past paper questions. Okay, but right now I am ending my class.